Okay, in the example 2 we have a semicircle. Look, this is the equation for the semicircle. And between -2 and -2 bounded by this. So basically it's a semicircle, the radius 3. The upper semicircle, but the region is this. Bounded by the semicircle and x2 and -2. When you rotate this, rotate around the x-axis and generate a solid. The solid is a sphere, but this sphere do not contain two pieces, so the lateral pieces, no? The right and the left pieces. Okay, so I need to find the surface area. Surface area. To compute the surface area, the first thing you should do is compute the derivative. Okay, y is equal 9 minus x squared raised to the half power. Therefore, y prime derivative is 1/2 9 minus x squared raised to the -1/2 multiplication by the derivative of the expression inside is minus 2x, no? Therefore, y prime is equal, okay, here es obvio que es minus, entonces these two is cancelled, entonces es just x over square root 9 minus x squared. Okay, this is expression for the first derivative, and this expression go inside the radical. This is square root 1 plus square root is x squared over, and square roots cancel out. Okay, now we try to put together condensing. This common denominator 9 minus x squared, and 9 minus x squared plus x squared. This is cancelled. Then is radical 93 over square root 9 minus x squared. Okay, let's continue with the formula. Okay, now the formula for the surface area is integral from -2 to +2, that's the limit of our solid, 2 pi multiplication by y, the y is the square root 9 minus x squared times the square root part, take this separately as 3 over square root 9 minus x squared dx, and this is cancelled. Wow, good, very good. The integral minus 2 from -2 to +2 of 6 pi multiplication 3 times 2 is 6 dx. Now the surface area is 6 pi. Integral dx is x, evaluate in between -2 and +2. So it's 6 pi is x squared is 2 minus 2 is 2 is 4, this is 24 pi. That's the answer. Then in the calculator, 24 pi. Is 75 approximately 75.3982. Okay, let me check in decimal the answer. Okay, look, I check it in decimals. This is my function. This is my limit, the lines. This is the region. And this is the integral. Look at the answer, the same answer. Very well, we're doing well. Okay, now example 3. In example 3, we have function, just a cubic root function, cubic root x. And bounded between y equal 1 and y equal 2, same between 1 and 2. So basically, our region is y equal 2. The line y equal 1. And the curve y equals square root x. This is our region. And this region rotate around the y-axis and generate a solid. I need to compute the surface area for this solid. Okay, this is the example in which it's much better doing in different way. So instead of doing in the traditional way, we are doing integration with respect to y. So say I putting explicit for you solve for x, for example, x is equal y cubed. Because in the formula I need to compute dx dy, not dy dx. And the derivative with respect to y is 3y squared. It's easier than differentiate with respect to x. Entonces the formula es square root 1 plus dx dy squared is now, in our specific example, square root 1 plus square this expression, you get 9 y to the 4th power. Okay, we set up the integral to compute the surface area. Is surface area is equal integral from 1 to 2 because it's the y value. So this thickness in this case the y to by the function is y cubed multiplication by square root 1 plus 9y to the 4th power dy. This is an integral I need to solve. Okay, for solving this integral I propose the following substitution. For example, u equal 1 plus 9y4. Therefore du is equal 36 get 9 times 4 y cubed dy. Y cubed dy is exactly the same we have here, but I need 36 extra. So you consider 36 here in the front and divide by 1 over 36. The surface area is equal. Actually is, and 2 divided by 36 is 18. So pi over 18 integral. I have no idea about the limit. But okay, we have square root u. Square root u. Okay, this and the rest is du. Okay, 36 y cubed du. This is du. Okay, nice. Now I'm going to find the limit of u value 1 here. 1 here is 1 to the 4th power is 1. 1 times 9 is 9 plus 1 is 10. And 2 is 2 to the 4th power is 16. 16 times 9 plus 1 is 145. 145. So this is pi over 18 integral from 10 to 145 of the u to the 1 here. This is pi over 18 and the derivative is u to the 3/2 2/3. Evaluation between 10 and 145. Okay, we can simplification a little bit here. Divided by 2 is 1, divided by 2 is 9, this is 27. Pi over 27. Evaluate 145 raised to the 3/2 minus 10 raised to the 3/2. We use a calculator, huh? Let me try. Now the expression expression is x raised to the 3/2. Okay. Evaluate at x equal 145. Okay. And evaluate 10. Okay. Now subtraction. Subtraction this minus this. Okay, it's expecting. This is the answer, but I want to multiplication by pi. No division. Division, no multiplication. Clear. And this expression. Multiplication by pi and divided by 27, sorry. I want to find the approximation. Okay, 199.48. 199.48 approximation. Let me check in this answer. Okay, in Desmos, this is our original function. This is the same function but expressed in implicit form. This is y1, y2 to horizontal line. This is the region, and this is the integral. And we check in the answer is exactly the same. Good, very good.